So hi, there's a problem which appeared in JEE Advanced 2019. So here we need to find out the determinant of a matrix, and that matrix determinant is provided as 0, right? And we need to find out, right, the values of required summation. Now here, just have a look on the elements of the matrix, right? So each and every element is in summation form. So therefore, first we have to find out each and every summation, and then we need to equate it to 0. And after doing it, right, we need to find out the required summation. It's a very interesting and important problem. So let's go ahead and start solve this. Let's go ahead. So first, we consider the matrix, right? So here, first we consider a matrix A whose elements we consider it as A, B, C, and D, right? So all the elements we consider. And where A is actually equal to summation of K is equal to 0 to N K, which is nothing but, right, we can easily say that it is sum of all element, right? So let's go ahead. If we write down, right, it is equal to k equal to 0 plus k equal to 1, then k equal to 2 plus so on, right? We can go ahead and add up to n, right? So therefore it's an AP series, right? It's an AP with first term, right? With first term, let's take it as 1, and number of term, right, is n, and the last term is also n. Now we know that for the AP series, sum of first n term can be written as Sn is equal to n by 2, the first term plus the last term, right? So using this, we can find out, right, the values of A is equal to n into n plus 1 and divided by 2, correct? That's it. Let's go ahead. Now here see that why we say the first term, because see that k equal to 0, right, doesn't have any meaning in the summation. So that's it. So therefore here, right, we able to compute the values of A that's equal to n into n plus 1 divided by 2. Okay. Now let's go ahead and play with the second element, that is B. Let's go ahead. Now, let's proceed, right, to take the element B, right? What is B here, right? The B here, obviously, the first row, second element, right? That is the summation, right? K is equal to 0 to N K square multiplied by N, C, and K, right? Now see that this summation, right, we'll find out using few tricks. Let's go ahead. So here that K squared term, right, can be easily written as K equal to 0 to N K into K minus 1, right, plus K multiplied by N, C, and K. So therefore, if I expand the summation, right, it is K is equal to 0 to N K into K minus 1 multiplied by NCK plus summation of K is equal to 0 to N K times of NCK. Now notice carefully, right, that when I put k equal to 0, this is 0, right? Because 0 into something. When I put k equal to 1, again 1 minus 1 is 0. So therefore, you can easily write down it as 2, right? So k equal to 2 to n. If I go ahead and see the next one, right, it should be k is equal to 1, because if I put k equal to 0, it doesn't have any meaning, right? Now, this we need to sum up, right? Now, see that the summation, we can do it in a spatial form. So first we observe what is actually happening for k times of nck. Okay, let's go ahead. So here we go ahead and take that, right? K nck. So see that here it is k. Let's apply the NCR formula. So therefore it is factorial n divided by factorial r, that means factorial k, and n minus r, that is n minus k factorial. Now if I rewrite it, right, we can say that it's k multiplied by factorial n, I keep it as it is, and k will be k times of k minus 1 multiplied by n minus k factorial, right? So k and k get cancelled, right? So therefore we can rewrite it as factorial n, right, divided by k minus 1 factorial into n minus k factorial, right? Now, what's the purpose of rewriting it, right? So see that the numerator here, right, n can also be written as in some spatial form, that n into n minus 1 factorial, right? That's it. So therefore, it can be written as n into, let's observe that. We can write it is n minus 1, that's fine, factorial. K minus 1, I keep it as it is, that's okay. But for the next one, right, I can easily write it as n minus 1 minus k minus 1 factorial. So therefore, it's became n multiplied by n minus 1 c k minus 1. So therefore, k n c k can be easily written as n into n minus 1 ck. So if I use that, right, in both cases, right, see that it gives you k equal to 2 to n k into nck, that can be written as k minus will be as it is n into n minus 1 c k minus 1. Okay. For the next one, right, it can be written as summation of k is equal to 1 to n, right? K and ck will be n into n minus 1 into ck. Now, observe carefully, right? We again have that, right? K minus 1 and n minus 1 ck, right? So if I take it as, right, in this particular problem, actually, right? If I take k instead of k, it is k minus 1, right? So nck minus 1. So therefore, it will be definitely equal to, right, that n minus 1. So n minus 1 will come out. So it will be n minus 1. N minus 1 is became n minus 2 ck minus 2, right? It's extension of this next formula. So just substitute k equal to k minus 1, n equal to n minus 1. So therefore, using that, right, it can be easily written as summation k is equal to 2 to n k minus 1. So therefore, n into n minus 1 multiplied by n minus 2 c of k minus 2 plus summation k is equal to 1 to n times of n minus 1 ck. Okay, that's it. Now let's go ahead, right? Now, whatever I did, right? Now, n minus 1, n into n minus 1 is the first summation, and then the second summation, right? N can be taken out from the summation because it is independent of the variable k. So, let's go ahead. So, therefore, observe carefully, right? Here, that b can be easily written as, let's go ahead, b is equal to, right? N into n minus 1 can be taken out from the summation. Summation k is equal to 2 to n. Then n minus 2 c k minus 2 plus n will be taken out. It is summation of k is equal to 1 to n. Then n minus 1 ck. Okay, that's it. Now here we'll again use, right, a concept called substitution, right? Let's go ahead. So for the first sum, right, if I consider that r is equal to k minus 2, right? So what happened? You can see that it is equal to n into n minus 1, right? Summation, okay? So therefore, if k equal to 2, r is equal to 0. So that's it, 0. When k equal to n, r is equal to n minus 2, right? Obviously, it is n minus 2 c of r, okay? Plus n. So here I consider r is equal to k minus 1. If I consider it, right, that when k equal to 1, r is equal to 0. When k equal to n, it is n minus 1 and n minus 1 cr. Okay, that's it. Now we know that, right, in a binomial theorem, right, we know sum of all the coefficient of 1 plus x whole to the power n is 2 to the power n. So what is the sum of all the coefficient? That means nc0 plus nc1 plus so on up to ncn, right? So therefore, in summation form, it is r is equal to 0 to n ncr is equal to 2 to the power n. Now notice carefully, right, in this particular problem, right, that first summation, right, will be n into n minus 1. R n minus 2 is there. So this is 2 to the power n minus 2. And for the second case, it is obviously n into 2 to the power n minus 1. And that's it. So see that therefore we can easily able to obtain, right, using that general formulas, right, that what is the value of B. Now see that here, obviously we can simplify the value of B, and it's better to do that in this step only, because notice we have to find out the determinant at the end, right? So that's why I take 2 to the power n minus 2 common. So if I take 2 to the power n minus 2 common, right, the first term will give you that n square minus n. And the second term, right, will be gives you that plus 2n, right? So therefore, we can easily write it as n into n plus 1, right, into 2 to the power n minus 2, right? So see that we are able to compute the values of B, right? So let's note down and write down the values of B. That is n into n plus 1 and 2 to the power of n minus 2. So all the elements in the first row is computed now. Let's go ahead and compute C and D. Now let's go ahead and, as I said, take C, right? So what is C? C is equal to summation k is equal to 0 to n, right? K times of n c k. Now see that in the to prove or find out the value of B, we already proved that, right? That K times of NCK is equal to N times of, right? N minus 1 C of K minus 1. So if I go ahead and use this formula, we can see that it's equal to summation K is equal to 0 to N, right? It is N multiplied by N minus 1 CK minus 1. Now here, right, obviously n will be outside and summation of, right? If I take that, right, r is equal to k minus 1, right? So r is equal to 0 to n minus 1 n minus 1 CR, right? Now we know that the summation of all the coefficients up to n term is equal to, right, that 2 to the power n. So here it will be n into 2 to the power n minus 1, right? So therefore, we are able to obtain now the values of C's as well, which is n into 2 to the power n minus 1. And that's it. Now, let's go ahead and find D. See that D is equal to here, the last summation is summation. K is equal to 0 to n ck into 3 to the power k. Now we know that, right? What is the binomial expansion of 1 plus x whole to the power n, right? We can say that it is equal to summation r is equal to 0 to n, right? That ncr into 1 to the power n minus r multiplied by x to the power r. by simplification, right, we can say summation r is equal to 0 to n ncr into x to the power r. Now, if I take x is equal to 3, my left hand sides became 3 plus 1, 4, and 4 to the power n, which is equal to, right, summation r is equal to 0 to n in CR into 3 to the power r. Now see that the pattern and this pattern, whatever we are looking for, are actually the same. So therefore, we can easily say that in this particular problem, it is the sum of all the coefficients, right? So therefore, it is equivalent to 4 to the power n. That's simple. So see that we are now able to find out, right, that all the values, right, in this determinant, all the entries in the determinant. Now let's write down the determinant. Now let's go ahead and find out the required summation, right? So what we are looking for here, right, that summation k is equal to 0 to n nck divided by k plus 1, right? Now here we already know that, right, that in this particular problem, my n is equal to 4, okay? But that's leave out, right? So now try to calculate this, right? Because this summation we just need to calculate. So I go ahead and say k plus 1 in ck, which is equal to 1 by k plus 1. That's correct. Now, if I expand it, it will be factorial n divided by factorial k into factorial n minus k factorial. Now, k into k plus 1 gives me that k plus 1 factorial. So it is factorial n divided by k plus 1 factorial multiplied by n minus k factorial. Now, this term can also be written as by take that 1 by n plus 1 n plus 1 outside. So therefore, it will be n plus 1 multiplied by n factorial. This is factorial n plus 1 divided by k plus 1 factorial multiplied by n minus n plus 1 and minus k plus 1, and that's factorial, right? So therefore, right, we can easily say that, right, it is actually equal to 1 by n plus 1, and then we can say that n plus 1 c k plus 1. That's it. So therefore, we can easily go ahead and rewrite the given summation as summation k is equal to 0 to n, right? 1 by n plus 1 multiplied by n plus 1 c k plus 1. Okay. Now see that it is actually n plus 1 is actually independent, right, of k. So I can write n plus 1. Now if I put the respective values, right, we can say that it is n plus 1 c of 1 plus n plus 1 c of 2 plus dot dot 2. It is n plus 1 c of n plus 1. That's it. Now see that it's a sum of all the coefficients but of a binomial expansion, but only n plus 1 c0 is missing. So therefore, we can easily rewritten as it's 1 by n plus 1 n plus 1 c0 plus all the terms, right, end up with n plus 1 c n plus 1. Now, as n plus 1 c0 is added, I have to subtract that as well. So n plus 1 c0. Now see that, right? That first two term, right, or first term in that open bracket can be equal to 2 to the power n plus 1 minus 1. That's it. So that's the required summation. But here, right, observe that, right, n is equal to 4. And for n is equal to 4, we are trying to find out the required summation, right? Because we obtained that, right, n is equal to 1. Now see that previous case also we can say that, right, n is equal to 1, right? Because if n is equal to 1, the determinant also be 0. We proved that, right? see that it is 1144 or something we came. We don't calculate that properly. If you want, you can calculate it. But that is obvious cases, right? So that's why I ignored it, okay? But see that if I consider that n is equal to 1 as well, right? So the required summation, if I consider it as s, that's equal to, when I take n is equal to 1, right? So therefore, it is 1 by 2 multiplied by, right, 2 to the power 2 minus 1, right? So it's 2 square minus 1. That gives you as 2 to the power 4 minus 1. So it's 3 by 2. That's 1.5. And if I consider that n is equal to 4, right? So therefore, we can see that it is 1 by 5 and 2 to the power 4 minus 1. So what is 2 to the power, sorry, 2 n equal to 4, so 2 to the power 5, I missed that. So therefore, the calculation will be 1 by 5, 2 to the power 5 minus 1, 32 minus 1 is 31, right? That's why it is 6.2. So therefore, for this particular problem, right, A's answer will be 1.5 and 6.2, right? Both are the possible answer, okay? That's it. But as a published result, right, in internet, right, or any other sources of that IIT, whatever they published, the answer in that particular exam is given as 6.2. So that's why we ignored n equal to 1 here, and because that n equal to 1 and choose it as n equal to 4. Okay, that's it. Let's believe that is correct. Okay, that's it. So that's it for this particular problem, which is lengthy but and difficult but interesting. Hope you understood the problem. Thank you.